Good morning, students. Welcome to my YouTube channel, Understanding Concepts. Our today's topic is R-2R ladder digital to analog converter, and this is of a current switch type. We have done voltage switch type R-2R ladder digital to analog converter in a previous lecture, and if you have not gone through that one, you can find out the link given by me in the description box. So here you can see this is the circuit diagram for the current switched R-2R ladder digital to analog converter. Here the main difference between the current switched and the voltage switched circuits are this part of the circuit where we are having the operational amplifier with the negative feedback resistance is being connected over here instead of the ground in the voltage switched network, and this here in this part we will be giving the reference voltage in the voltage switched circuit. So here we are having the resistances connected in the circuits. Here this is the A1, A2 and A3 where we are going to provide the digital inputs, and here we are having the 3 points. That means this particular circuit is for converting the 3-bit digital data into the analog. If we want to connect more than 3 bits, then we will be having more parallel or the shunt resistances over here, and we will be having more than 3 bits over here to be provided up to n also. So for this particular circuit, we have, when we are going to find out the output voltage here, that will be the correspondence to the input digital input provided over here. Then to find out this voltage, first of all we will consider the input being provided over here. Here this is the voltage being provided, and this will be the, because this is the current switched network, so this will be converted into the current. That I current will be equal to the voltage over the equivalent resistance. Here with the equivalent resistance we means the total resistance, total effective resistance of this part of the resistance. And when we are going to find out the total resistance with the help of the series and the parallel combinations of the resistances, then we will find out that this total equivalent resistance is equal to the R only. So the current here, this one current I that is entering into the circuit will be equal to the voltage provided over here and R, that is equivalent resistance. So the output voltage formula is equal to the minus I dash and feedback resistance RF. Here the I dash means we will be taking here the current entering into the operational amplifier will be known as the I dash only. So when we are going to find out the I dash, then I dash will be equal to the I by 2 plus I by 4 plus I by 8. These I by 2, I by 4 and the I by 8 are the currents of these branches, particularly when this current is entering here into the circuit. Here we are having 3 branches, 1, 2 and 3. Then the current into these particular branches will be divided over here. This will be the portion I by 2, this portion will be having I by 4, and this portion will be having I by 8, eighth part of the total current that is entering into the circuit. So this will be equal to the I dash over here, because here we will be adding all the currents coming here into the branch over here. So this will be I dash is equal to the addition of all the currents. So we can also write it as I dash is equal to I by 2, I by 2 raised to power 2, I by 2 raised to power 3 and up to I raised to power 2 raised to power I over 2 raised to power n. This will be for the n bit, and this current equation I dash is for the 3 bit suppose, and then you can find it this equation for the n bit. So we can also write it in the terms like in the input terms. Then this is a n by 2 raised to power n plus a n minus 1 2 raised to power 2, like this up to the a1 into 2 raised to power n into 1. Which one particular input is 1, that will be considered over here, all other will be 0. With it, by taking an example, like for example we are having the V is equal to 8 volts, like this V which we are providing as input voltage or the reference voltage. R is equal to 2 kilo ohms. Our feedback resistance here, this is suppose given as a 2 kilo ohm again, and suppose we are here providing the digital data, that is 3-bit data 100 to be converted into the analog voltage. Then if this is 100, that means A1 here, because here we are considering the MSB and here we will be taking the LSB. So MSB over here is 1, that means A1 is equal to 1, A2 and A3 are 0. So first of all, finding the I current of the circuit, that will be equal to the V over R, that means 8 over 2 kilo ohms. Here we will be getting the 4 milliamperes. This is the current here that is entering into the circuit. So after that we will find out the value of I dash, that will be according to this formula, that will be equal to 1 over, because this is a 3-bit data, so we will be taking it as 2 raised power 3 into I. Here I we have find it as 4 milliamperes. So 4 milliamperes over 8 will be equal to 0.5 milliamperes. So after this we will be finding out the total output voltage, that will be equal to minus I dash into RF, that is a feedback resistance. So that will be equal to V naught is equal to minus I dash RF, that is I dash we have calculated over here as 0.5 milliamperes. This is minus over here into this is the feedback resistance, that is given as 2 kilo ohms, and this kilo will be cancelled by milli, so it is equal to minus 1 volts. So that means when we are going to provide the 100 digital input, the analog reference output, the output voltage will be, analog output voltage will be 1 volt. If someone is asking for the magnitude of the output voltage, then you will be telling it as 1 volts. If they are like asking for the sign also, then you will be taking it as minus 1 volt. Otherwise this is a 1 volt magnitude voltage. So this is a R-2R ladder, a digital to analog converter, and this is of current switched type. The another voltage switched type I have also explained in my previous lecture. You can also find out the link in the description box. We are also having one more digital to analog converter, that is a binary weighted resistor digital to analog converter. I am also giving the link of that particular topic in the description box. You can check all the topics from there. So thank you for today.